Good morning, our PKO lectures. So today we are from Group 6 are going to present you about our last experiment, which is clove oil isolation from clove. The objective of this experiment is to study of isolation method of clove oil from cloves with steam distillation and study of thin layer chromatography. First, we are going to look at the theoretical basis. First, essential oils are the group of vegetable oils or oils derived from herbs that have a distinctive aroma. One example of essential oils is clove oil. Clove oil is a phenol essential oil that utilizes flowers and leaves. The largest components contained in clove oil consisting of eugenol acetate, and beta-caryophyllene. And the three compounds are non-polar properties, which is compound that used due to the presence of a bond between electrons on the elements that forming it, slightly soluble in water and easily soluble in organic solvents. Extraction is a process of separating substance from a mixture by the division of a solute between two solvents that cannot mix to take the solute from one solvent to another solvent. Extraction can be divided into solid-liquid extraction and liquid-liquid extraction. In this experiment, liquid-liquid extraction used to divide two solvents. Liquid-liquid extraction is based on the difference in solubility to separate the components of a mixture by contacting other liquids by using a separator funnel. Distillation is a purification process for liquid compounds, which is preceded by evaporation of liquid compounds by heating, condensing to form vapors and will be collected in a separate container to obtain distillate. The process that occurs in distillation is the change of liquid phase to the vapor or gas phase by boiling and condensation. Steam distillation method was used in this experiment because steam distillation is used to purify substances or liquid compounds that are insoluble in water and the boiling point is quite high. Steam distillation is based on the filtration process of a mixture of water and materials that insoluble completely or partially dissolve by lowering system pressure, so the distillation results obtained are below the initial boiling point. Thin layer chromatography or TLC is a chromatography technique that used to separate the components of a mixture using a thin silent phase supported by a buffer solution that used in refining and identification process chemical compound. The principle of TLC is separation of component based on their distribution on the stationary phase and the motion phase. Based on its component, TLC consists of stationary phase, which is silica and cellulose powder, and motion phase, which is mixture of two organic solvents. The qualitative analysis on TLC based on sizing and RF or retardation factor value, which is distance relative component to solvent distance, which is compared to the standard point. These are the materials and equipment needed in this experiment. In the procedure of this experiment, for detailed procedure can be seen in this section, but overall, the process in this experiment began with distillation, extraction with the addition of dichloromethane, evaporation of dichloromethane to obtain clove oil, TLC process using standard eugenol and clove oil, and index refractive analysis. Next.
This is the data experiment results and data processing.
This experiment, cloves oil is obtained by extracting the oil from cloves powder originating from flowers, stems, and leaves from cloves plant. Based on the research, there are three types of main compound existing in cloves, that is eugenol 70 till 85%, eugenol acetate 15%, and beta-caryophyllene 5 until 12%. Extraction process of the cloves oil is done with steam distillation on clove powder. In this distillation process, clove powder are needed to be mixed with water. It is because the boiling point of the constituent compounds in clove oil have high boiling point. So with water added to the cloves powder, it will cause formation of a mixture that is heterogeneous. This causes the fulfillment principle from Dalton's theory that states that vapor pressure from non-homogeneous mixture equals the total of its vapor pressure of the pure compound. So the vapor pressure of the mixture of cloves powder and water will be bigger than the vapor pressure of pure cloves oil. Mixture becomes easier to evaporate and the extraction process will be faster. In this experiment, 30 grams of cloves powder added in a 2 neck round bottom flask and later added with 100 milliliters of water in a flask, and 100 milliliters of water is also added to the dropping funnel, which later will be added to the round bottom flask with adaptable rate that can be changed and be equalized with the rate drops on thin starch equipment. This is because at the distillation must be done fast, so the condition where the water inside the flask is not too much but also not too little. The distillation process also uses tin star canister, which serves to measure the volume of the distillate octane. Besides that, actually with the use of tin star, the oil could be separated with existing water because they are shaped like a burette and there is a control valve. However, in practice, the whole distillate octane will be continued with the extraction of the clove oil from the distillate. 15 milliliters of dichloromethane is then added to the distillate and into the separatory funnel. The separatory funnel is then shaken and the pressure is set by opening the valve. Dichloromethane is chosen as a solvent because clove oil dissolves more in dichloromethane compared to water. Besides that, dichloromethane doesn't dissolve in water, so there will be two layers. Properties of the dichloromethane that is highly volatile is also one of the reasons why dichloromethane was chosen as a solvent. The mixture of dichloromethane and clove oil evaporated inside the fume hood using hot plate stirrer. Evaporation process carried out at the temperature of 60 degrees Celsius. This is because the boiling point from dichloromethane is 39.6 degrees Celsius, so the evaporation process could be faster. The evaporation process is done until the dichloromethane aroma is gone and the typical aroma from clove oil starts to get smelled. Then the bitter glass and the clove oil is freed. Analysis with TLC is done by comparing the distance from clove oil obtained with eugenol standard on TLC. The elements used is mixture from hexane and dichloromethane with comparison 2 and 1. In the experiment, 6 milliliters of hexane and 3 milliliters of dichloromethane were used. Then the TLC paper is limited with start line and the finish line, and the standard eugenol and clove oil were dripped on the TLC. The TLC paper then dipped into the L1 that is inside the L1 chamber and allowed to stand there for 20 till 30 minutes. In the process of analysis, don't let the point from the sample on paper dip with L1 because it will cause the sample or standard eugenol precisely dissolve in the L1 and doesn't move along with the movement of the L1. Then the results obtained was seen with the use of UV light. Besides the TLC analysis, the refractive index analysis is also used by refractometer, which is a tool used to measure index from refraction or refractive index. The more similar refractive index with the pure substance show that the clove oil has a high amount of eugenol. From the experiment result, the mass of the clove oil is 2.284 grams, so the yield obtained is 7.6133% weight per weight. The theoretical oil content is 15 until 20% weight per weight, which means that the percentage of the error is 49.2447 until 61.9335%, which with an accuracy of 38.0665 until 50.7553% weight per weight. The error can happen because of the limited time for the practice, so not all of the clove oil are distilled from the clove water. For the TLC result, the retardation factor of a standard eugenol is 0.782, meanwhile for clove oil the retardation factor is 0.745. The retardation factors don't have a big difference, which can be concluded that the clove oil has a high purity of eugenol. The result of the refractometer, the clove oil refractive index obtained is 1.5105, whereas the theoretical is 1.5195 until 1.5210. So the obtained error percentage is 0.5923 until 0.6903% with an accuracy of 99.3097 until 99.4077%, which means that the clove oil obtained is a pure clove oil.
Last, for the conclusion, the clove oil isolation is a method to obtain clove oil through clove powder by steam distillation within star trap by lowering the vapor pressure of the solution, resulting in the boiling point of the mixed solution decrease so that it is easy to evaporate and collects the condensate steam during the distillation process and holds a distillate consisting of two layers that do not mix with each other due to lower specific gravity when compared with water. Through these experiments, TLC is used to separate the components of eugenol standard and clove oil to obtain the distance for retardation factor. Moreover, the eugenol purity content in clove oil in this experiment was 99.3097% until 99.4077%. Next. So these are the bibliography that we use in this experiment. Next. Last, thank you for listening our presentation.